and I don't think there's anything else I would rather do. So
Fair enough.
all right, ladies and gentlemen, let's go ahead and jump in. Today we're going to focus on the ellipses, but you do want to be aware of what type of equation will create an ellipse. So just as we've been doing, if you could go ahead and classify numbers 1 through 7 as circle, parabola, hyperbola, ellipse, or maybe a line. So if you could try numbers 1 through 7, I'm going to walk around. If I can help you in any way, raise your hand if you have a question, or I'll see if I can catch any misconceptions before we begin. So try numbers 1 through 7, and then we'll share. All right, guys, it's the last block new lesson of the semester. So I thought I'd put out some candy for some answers that you guys provide. So for a chocolate Hershey's Kiss, raise your hand if you tell me for number 1. What would be that conic? Charlie? Ellipse. He's correct. Charlie, how'd you know it was an ellipse?
It has positive on both.
Has positive on what?
The exponents.
The x squared and the y squared, and they're different coefficients. Nice. Someone try number 2. Sergio.
Circle.
Circle. How do you know it was a circle?
Same coefficient and the same sign.
Same coefficient on the x squared and y squared and the same sign. Perfect. All right, how about number 3? Cynthia.
Ellipse.
Ellipse. You're correct. How did you know it was an ellipse?
Because it has 2 as the exponent.
Nice. Different coefficients on positive x squared and y squared. Ready for someone to get out of it. I'm sorry. Hey, you got it. And I threw it. It works. All right, number 4. Azra, what do you think?
Parabola.
Parabola. Awesome. Parabola. How about the next one, guys? Number 5. It's got a positive x squared and a negative y squared. Caroline? Hyperbola. She is correct.
I can never pronounce.
It's good. You had it. Totally good. I'm going to walk over there in a second, Caroline. How about number 6, guys? Christian?
Line.
Line. Awesome. There's no squared terms, just an x and a y. I'm going to walk over there in a minute. And then the last one, can someone raise their hand and tell me, Emily, what do you think? Hyperbola. Correct. All right. Once you know how to classify the equation, then you can put it in its proper form to use to help you graph this specific type of conic. But the next type of conic that we have to look at graphing is an ellipse. We have not gotten there yet. An ellipse is basically like an oval. It's a elongated circle. And you're going to find that the standard form of an ellipse looks actually similar to that of a circle. So here it is. I'm going to give it to you, and then we'll focus on what the pieces mean. Standard form of an ellipse looks like x minus h squared divided by a squared plus quantity y minus k squared divided by b squared is equal to just the number 1. So the similar component to a circle is the x minus h and the y minus k squared. What do you think hk represents in terms of an ellipse? What do you think, Min?
Can we go down there? It's cool.
I don't think I wish it was better, but I don't. Is it like blowing on you?
Yeah, kind of.
You don't have a sweater?
No.
I don't know if it's gonna be better. I mean, you can go for the notes, but then you'll have to come back for the group work, okay? So the HK, any ideas of what that could be? The center. Now, looking at the a squared and b squared, that piece is different, also the number 1. The a is gonna tell you how wide the ellipse is. It'll tell you, in fact, just go ahead and point to it. You're going to move a units. Notice the a is under the x variable. So you're going to move a units in the direction of the x-axis. That would mean left and right from the center. It's going to tell you how wide your ellipse will be. Then the b value, so that's move a units in direction of x-axis. The b value is going to tell you to move b units in the direction of the y-axis, up and down from the center. So go ahead and write it, and then we'll look at an example of what that looks like. So we're going to move b units in the direction of the y-axis, which would mean up and down from the center. The easiest way for me to remember it is the b value is always under the y. So that tells me go in the direction of the y-axis, which is goes up and down. The a value is always under the x. So that reminds me go in the direction of the x-axis, which is always moving left and right. Let's see how this works in an actual number example. So let's start graphing. First of all, what would be the center? What would be the HK of this specific ellipse?
2, 1.
Perfect, 2, 1. You took the opposite of what you saw in the parentheses. So we're going to go 2, 1. There's my center. Now my A value is found underneath the X. It's not 9. What do I have to do to 9 to find the A value? Square root it, awesome. So I'm going to go 3 units along the X-axis from the center. So I'm going to go left and right. I'm going to go left 3 units, and then I'm going to go right 3 units. In a similar fashion, to find the B value, it's not 4. What do I have to do to 4? Square root it, good. And now I'm going to go in the y-axis direction. So the y-axis goes up and down. So from the center, I would go up 2, and I would go down 2. And now I have how wide and tall this ellipse is. It's not a perfect circle because it doesn't have one length radius. It's elongated. It's an ellipse. All right, let's try it again. Actually, the first thing I would ask you to do is turn to your partner and tell them what the center is and the A and B value. I'd like the person with the most siblings in this group to share what the center and the A and the B value are. Well, how many siblings do you have again?
I have one older sister.
One older sister. Okay. I have 2. I have a brother who's older, a year older, and then my sister's 9 years younger.
Fair enough.
So I'll go ahead and do this one. The center is -3, -1. And then the A value would be the square root of 1, which is 1. And the B value is the square root of 16, which is 4. All right, guys, go ahead and check. You should have a center of -3, -1, an A value of 1, a B value of 4. Now let's put those pieces together to graph this shape. So I'm going to go -3, -1. And then in the X direction, so left and right, I'm going to go left 1, right 1. In the Y direction, which is up, down, I'm going to go up 4 from the center and down 4 from the center. And this is not a very wide ellipse. It's pretty long. If we identified conics in more, if we looked at conics in more depth, we would say that the major axis of this ellipse, the line that goes all the way up and down, would be 8 units. You guys will learn that more in more depth in pre-calculus. All right, that's graphing an ellipse. Any questions on how to graph? All right, then let's move down to what do we do if it's not in standard form? We just learned standard form, so let's rewrite it. It's standard form in an ellipse is x minus h squared over a squared plus quantity y minus k squared over b squared is equal to, do you guys remember without looking at 1? Good. It's not a radius squared, it's just equal to 1. So what do we do if the equation is not in that form? Well, we're going to have to, again, complete the square. So let's see how we do that. The first thing you're going to want to do is group the x's together and group the y's together. So right now I have 25x squared and 100x. So I'm going to group 25x squared and 100x. And then I'm going to group the y's. So I have 4y squared and negative 8y. And then I have equal negative 4. Now I know you all know how to complete the square, but what are we going to have to do first with both of these x's and these y's before we can complete the square? We're going to have to take out a GCF because we have to get x squared by itself and we have to get y squared by itself. So if I'm looking at the x's, the GCF that I would factor out would be 25. And I would divide that out and that would leave me with x squared plus, what's 100 divided by 25? 4, good. So I'm going to have x squared plus 4x. Now I'm going to complete the square in the parentheses. But let me go ahead and factor out those y's first. What am I going to factor away from the y terms? 4, good. So if I factor out a 4, I'll have y squared minus 2y. And then I still have is equal to negative 4. Now that I've factored that guy away, I can complete the square. So quick reminder of how to do that. Take the middle term, divide it by 2, and square it. Half of 4 is 2. 2 squared is 4. But now, what number do I need to add to the other side of the equation? Is it just 4? It's 100. Awesome. I have to take into account that distributive property. So I have to take into account 25 times 4. So I'm actually going to have to add exactly 100 because that's 25 times 4. All right, let's do that again with the y terms. So if I look at what do I need to add to the y's, I take half of 2, which is 1, and square it. Now I'm adding 1 inside of the parentheses, but what do I need to really add to the other side of the equation? 4, awesome, 4 times 1, which is, we know, just 4. Okay, now that I've created what we call a perfect square trinomial, I can factor it down to just something squared. I have 25 times x, is it going to be plus 2 squared or minus 2 squared? Plus, good, because that middle term is positive. So I have x plus 2 squared plus 4 times, is this going to be a y minus 1 or a y plus 1 squared? Good, y minus 1 squared is equal to, and now let me add up all these numbers, negative 4 plus 4 is 0, so 25 times 4 is 100. I am so close, but what is the equation equal to for an ellipse? 1. So how do you think I could make this equation equal to 1? Perfect. Divide it by 100. Divide this side by 100, and when we divide this side, we have to divide everything on that side. And now I can reduce. How many times does 25 go into 100? 4. So this is going to become x plus 2 squared over 4 plus, how many times does 4 go into 100? 25. So I have plus quantity y minus 1 squared divided by 25 is equal to 100 divided by 100 is 1. And now I can go ahead and graph this. What would be the center? Good, negative 2, positive 1. And then what would be the value of A? Good, the square root of 4, which is 2. And then how about the value of b? 5, the square root of 25, which is 5. Now I have all the pieces I need, so I'm going to go and graph the center, which is at -2, 1. And then I'm going to go in the x-axis direction. I like to look right under the x. I'm going to go 2 units left and right from the center. Then in the y-axis direction, I like to look right under the y and see that I'm going to go 5 units up and down. So I go up 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5. And there is the equation of my ellipse. Cynthia. Yes. All right, number 2, I'd like the person with the least amount of siblings in the group. If you could turn and tell just your partner what you would do first, and then you guys can finish it together.
The first thing you would need to do is subtract 42 from both sides.
Nice. And then you're going to group the x's together and the y's, right?
Yeah. So that'd be x squared minus 6x plus, well, then you'd like put the space in between for the addition and whatnot. So then plus 4y squared plus 24y equals -41.
Awesome. Well, I'm going to stop you there because I just want to make sure the whole class got that, what you got.
Cool.
You guys, check to make sure that you subtracted the 42 to the other side. This one was different than the other because the constant was on the left side, so we had to move it to the right. Now we can go ahead and start completing the square. Looking at the y's, what do I need to do before I can complete the square with the y's? GCF. What's the GCF of 4y squared and 24y? 4, good. So I'll take that out, and I have y squared plus 6y equals -41. The x's, I don't need to factor anything out because x squared is already by itself. Now, looking at the x's, if I'm completing the square, I take half of 6, which is 3, and square it. So 3 squared is 9. What do I have to add to the other side of the equation? 9, good. Looking at the 6, I'll take again half of 6, which is 3, and square it, which again is 9. But what do I need to add to the other side of the equation?
36.
Good, 4 times 9, which indeed is 36. And now I can factor this down. So this will create an x minus 3 squared plus 4 times quantity y plus 3 squared is equal to, and now I need to add these up, -41 plus 9, give me -32 plus 36 is 4, I believe. But thinking about standard form, what do you have to set the equation equal to? We have to divide by 4, correct, because we do, yeah, we need to set that equal to 1. But when we divide 4 by 4, it does come out to equal 1. So now I have x minus 3 quantity squared over 4 plus 4 goes into itself how many times? 1. So this is just going to be y plus 3 squared over 1 is equal to 1. Now, on your own, see if you can graph this, and then we'll check it up here at the screen. All right, guys, go ahead and take a look. You should have had the center at 3, -3. You should have gone left 2 units, right 2 units from the center, and up 1 unit, down 1 unit from the center to create the shape of the ellipse. Any questions on that? Okay, the next thing I'm gonna ask for you to do is download the group work. It's under your assignments. So if you look at the assignments, it's technically an in-class homework grade.